Welcome back to the channel, and in this episode we're kicking off an epic new project, the go-kart. And that's because this channel needs a go-kart to use for engine testing. Well, sort of. Oof, this thing's big. Well, it's a little bit bigger than a traditional go-kart, and that's exactly what we want. Big and heavy. So it turns out, this thing's an HS800 UTV, and it was built by Hisun. Basically, it's one of those no-name UTVs that were sold under a bunch of different names, like Hisun, Messino, Axis, Dynamo, possibly Cub Cadet, and maybe even Remington. Forgive me if I missed a few names, the list is very long. Back in the day, you could practically get these things in a box of Cracker Jacks. Basically, this was the rig that was available anywhere except the dealer. The one that we just picked up is a Dynamo Discovery 800, and that's just what the sticker says. The truth is, it's a Hisun 800 Strike. From what I'm told, and I'm not 100% sure, this is a copy of a Yamaha Rhino side-by-side. Who knows if that's actually true? I'm not familiar with the Yamaha Rhino. Now, generally, you can get these things secondhand for cheap. This buggy is a 2010 model with low hours, and it's actually in very nice condition. So the word on the street is, the reason you can get these things cheap is, well, there may be an issue with quality. Also, parts and service is pretty much non-existent. At least in Kansas, that's very true. The good news is, this buggy suffered a catastrophic engine failure early on in its life, and it's been parked in a barn for many years. It's kind of a time capsule. As a matter of fact, it still has the original tires on it, and they're in great condition. So that's sad, it didn't run long enough for the tires to wear out. Now, aside from possibly a few nuts and bolts, this thing is 100% complete. It may not look it right now, but I have all the body panels and doohickeys to put this thing back together. Except, as I mentioned, the engine is no good. Again, that's great news because we want to do a Predator engine swap on this thing so we can test out a whole bunch of Predator engine mods that we have planned. Now, this thing is four-wheel drive, and that's a big problem when doing engine swaps. You see, the drive shaft for the front axle passes through the engine block on the original setup. It's going to be a bit tricky, but we already have a plan, so no worries. Fast forward a few minutes and the go-kart's off the trailer. Now we can get a better look at it. You know, this thing weighs over 1,000 pounds and it's like a little car of some sort. I reckon the roll cage, the four-wheel drive, plus all the gizmos really add up. This thing even has an electric winch on the front. Now, I don't think I'll ever use this, but we'll check it out and see if it works. Now in the engine bay, there's nothing at the moment. However, this space used to be filled with a fuel-injected 800cc V-twin engine of some sort. The engine was manufactured by Hisun, and it's the Achilles heel of these rigs. Now, to be fair, with all the body panels in place, gaining access to the engine was very limited, which doesn't help with the necessary routine maintenance and inspections. It's possible these go-karts would have had a better chance if access to the vital components were a lot easier. You know, when you make stuff inaccessible, folks are just not going to take the extra step to ensure the drive system's in good shape. Obviously, all the body panels are off at the moment, and that's because of the unspeakable things that happened to the engine, and the previous owner had to remove all the panels in order to pull the engine. The plastics for this buggy are very thick and well made, which is surprising. Anyway, all this stuff is pretty much in like new condition, which is very nice. The utility bed is also nearly perfect with very little wear. I reckon there's not a lot of miles on this buggy. Aside from the notoriously sketchy engine, the rest of this buggy is considered to be well built, and there are very few complaints about the suspension and chassis of these low-cost UTVs. The welds and general fitment of stuff appear to be about the same as you'd expect on a Japanese equivalent off-road machine. It's really a shame, you know, a lot of effort went into building this thing. As mentioned, the engine is foobar. The exact point of failure is unknown, and unfortunately that information has been lost due to this buggy changing hands a few times since its demise. It's suspected that the engine overheated, and who knows what damage that caused. I feel like it's just too much of a risk to put this thing back together just to find out the engine truly is no good. It's interesting. This V-twin engine was overhead cam and it had 4 valves per cylinder. Allegedly, this engine made 33 horsepower, which should have been plenty for a bit of off-roading fun. We'll get back to the engine and our plans later on in the video, but first I want to do an inspection of the various components to ensure we have a good foundation for our engine swap project. Fast forward a few minutes and I brought this thing into the shop. Now, since the engine is the primary cause for this being off the road, chances are the rest of this contraption is still in serviceable condition. Let's find out. The very first thing I did was pull the fuel injection harness because we won't be using this setup. If you recall from our other videos, we have the stupid simple fuel injection that we developed, and that will be going into this thing at some point in the near future. The fuel injection for this buggy was provided by Delphi, which is interesting. Normally I would expect to see a generic no-name ECU on something like this, but apparently that's not the case. Anyway, I think this is an early version of the Multec EFI series. The EFI harness is completely independent of the main harness except for this 9-pin connector. I reckon this is the gateway connected for such things as power, ground, a lead for the fuel pump relay, a tachometer lead, a temperature gauge, and a check engine light, and possibly the diagnostic interface. Hopefully removing this fuel injection system doesn't cause problems. This is interesting. The engine had dual oxygen sensors, one for each cylinder bank. So some effort was put into calibrating the fuel injection system for a V-twin engine. You know, that's a detail you normally wouldn't expect on a low-cost hoopty like this. Anyway, this stuff will go into my fuel injection stash for future use. The rear axle on this rig is equipped with a push-button locker, and we need to verify that it still works. So I reckon we need to give the battery some juice and see what works on this thing. It would also be interesting to see if the winch works, although I doubt I'll ever use it. The front axle on this buggy has electric doohickeys to engage the four-wheel drive, and we'll need to check that out as well. Right here is the drive shaft input for the front axle, and right now this thing will spin, but the wheels don't move. Oh, as a bonus, it would be nice if this gauge cluster works, and we can find out how many miles this has. My guess is it has less than 1,000 miles. This guy on the dashboard is the combo rear axle locker switch and the four-wheel drive switch, so we'll have to check that out. But before we do anything, we have to give the battery some juice. Oh, by the way, the battery has a 2014 date stamp on it, so this is the second battery. Jumpers connected. Let the fun begin. No spark, no smoke. Well, that's both good and bad. Let's flip the ignition key and see what happens. Whoop! This thing only has 1,150 miles, so it barely made it over the 1,000-mile mark. Good job, Hisun. This must have been one of the better ones. You know, it's too bad this thing never really got used. Oh, it has a tachometer and a speedometer. Very nice. So this is the button for the locker rear axle. Pushing this should lock the axle up for better traction. Now, when I spin this wheel, you can see the other wheel doesn't spin, so right now the differential is open, which is good for normal driving. So let's push the button and see if the axle locks. Wow, it actually works. That's incredible. Well, now we can put a check mark next to the locker option. So spinning this doohickey should make the front wheels spin, but right now nothing happens. Let's switch this over to four-wheel drive and then press the button for the front axle. Nice, we have four-wheel drive, and the other wheel spins too. Double nice. Okay, let's turn the four-wheel drive off for now because I don't think we're ready for that yet. Let's check the winch. Yep, the winch seems to work. I had my doubts, but I've been proven wrong. Very nice. Of course I'll never use it, but it's nice. Well, it's hard to say how much longer this thing will last, but it's in good enough shape for what we'll use it for. So, in my little town, these ATVs can be made street legal with a permit and proof of insurance. So this rig is kind of like a street legal go-kart, and that's our plan. Now, once you get out of town, there are hundreds of miles of secondary roads that this can be driven on without any issues. This buggy will blend in with the rest of the ATVs, and no one's going to know we're having fun and doing our engine modification testing. You know, I love bending the rules. Alright, well, let's go ahead and take a look at the broken engine again. So on the table, we have the failed engine separated from the dual range transmission that we want to keep. And over here you can see the drive shaft for the front axle. Well, this is not the whole drive shaft, it's only the part that passes through the engine block. Anyway, this is where it gets complicated. In order to keep the four-wheel drive, we'll have to keep this drive shaft, so it's going to be a bit tricky, and we'll get back to this issue in a moment. Well, the first thing is, we confirmed that the engine spins in the same direction as the Predator engine. You know, you wouldn't think that'd be a problem, but on some UTVs like Kawasaki, the engine spins backwards. Now, the primary clutch that was used on this engine cannot be reused due to it being made for a tapered shaft. So we'll be using a Comet 780 series primary clutch on the Predator engine. We ended up getting a generic version of the 780 for $115, which is very reasonable. Now, for the secondary clutch or driven pulley, we're going to be using the one that came with this Buggy. You know, it appears to be in really good shape and the belt is compatible with the 780 primary clutch. So the transmission used on this machine has a high range and a low range for forward and a single speed for reverse. The four-wheel drive select is not part of the transmission and it's done by solenoids on the front axle. Anyway, the ratio for low gear is approximately 5.1 to 1 and for high it's 2.9 to 1. The ratio for reverse is unknown, but it's likely the same as the low range ratio. Now the input shaft is 20 mm, which is more than 3/4 of an inch. If the driven pulley was not going to be used, I reckon this shaft could be machined down to 3/4 inch and then it would need a slot for the keyway. It's an option that we have, but for now we want to use the pulley that came with this rig. Now here's an interesting bit. This transmission has oil lines going to it, and I'm not sure if these are for an oil cooler or they connect to the front differential. We'll figure that out at some point. So this shaft nub plugs into the rear differential and it kind of aligns everything. The mounting bracket along the bottom of the gearbox connects to the chassis and it has flexible isolation pads. This bracket here is the torque mount and it bolts solidly to the chassis, but there is a rubber-like bushing for this pass-through bolt to provide some isolation and flex. So the transmission was designed to have a bit of flex because it's actually part of the rear motor mount system, when you consider the engine is normally bolted solidly to this guy in the original application. Now, where the drive shaft connects for the front axle, there's a support bearing inside the case to support the internal shaft. So, if we didn't want to keep the four-wheel drive option, we could machine something similar to this thing just to cap off this hole, and the Buggy would only be two-wheel drive. It makes things a lot simpler. However, we are going to retain the four-wheel drive, despite the fact that it'll never likely get used. Okay, let's talk about the drive shaft and how to deal with it. Well, unfortunately on this rig, the drive shaft passes through the original engine block, and this engine's going to be replaced with a Predator engine. So, we need a way to keep the drive shaft, which really isn't a problem, but it means the Predator engine's going to have to mount about 4 inches higher with our new custom motor mount brackets and platform. Mounting the engine higher poses a problem if we want to keep all the plastic panels intact. So our plan is to use the Predator 420, and I guess the 459 would also work. However, we do have a 420 in stock, so we'll use that to keep our expenses down. Now, the 670 V-twin would be more ideal, I get that, but I'm not sure it'll fit. It may or may not. It's going to be real close. Once we get the 420 mounting system figured out, then we'll have a better idea if the 670 will fit. Now, what I do know is the 420 will fit, and I already have one in stock, and that's the direction we're going to go in right now. So the motor mount bracket is simple stuff. Keep in mind this channel put a 212cc Predator in a Honda Insight, then we upgraded to a 420cc Predator with both a supercharger and fuel injection. We also put a 3-cylinder Kubota diesel engine in a Saturn Coupe, and we put the same engine in the Honda Insight. Plus, we also dumped a 670cc V-twin in a 1969 Renault. Engine swaps are no big deal for us, and this is a simple engine swap, so no worries. Alright, back to reality. Now, the drive shaft is still an issue. You see, the bearings here and here are expecting crankcase oil for lubrication. So, we're going to have to enclose the drive shaft in a tube so we can maintain adequate lubrication. Of course, the drive shaft tube will get attached to the motor mount bracket in some way. The tube fabrication is possibly the hardest part of this whole engine swap, and it isn't very difficult at all. The parts have been ordered, and I'm excited to get started on it. So off camera, I went ahead and placed some of the body panels back onto this rig. It kind of looks funny without the roll cage, but for now we have to leave the cage off in order to have clear access to the engine bay. Anyway, with the important panels on, I was able to take some measurements for the available space in the engine bay. The center console provides additional clearance for the extra 4 inches we're going to need to mount the Predator 420 engine. Of course, when this project is finished, I really would like this buggy to look completely normal and not all hacked up. So getting this engine to fit is very important. Now with the seats and all the panels in place, there's absolutely no access to the engine bay, and I find this to be ridiculous. You know, some manufacturers have a lot of confidence in their products and designs and can get away with limited access. However, for perhaps a manufacturer with less than ideal quality, I think giving the customer full access to the engine may help prevent premature engine failures. For Hisun, the decision to copy a Japanese design is, well, it's an okay shortcut. But I feel like the decision to copy limited access destroyed any chance they had for brand loyalty. It's just that simple. From what I've seen so far, this thing ain't bad, and they got a lot of stuff right. But I think they had too much confidence in their product, and that's something the Japanese have had decades to learn and improve on. Anyway, it works out in my favor because I got this low mileage go-kart for crazy cheap. So with the body panels off and the transmission in place, you can see how this all fits together. The new engine mounting system will put the engine above the drive shaft, and that's going to eat up a lot of space as far as height goes. Unfortunately, it's the only way to do it. Now, eliminating the drive shaft and making this thing two-wheel drive will allow the engine to be mounted lower in the engine bay, and at that point, a bigger engine is possible. In this picture, you can see the 420 engine on the left and the 670 V-twin on the right. Now, this comparison is very close to actual size. Both engines take up a lot of space. However, on the 420, we can get rid of the fuel tank and then route the exhaust so it goes down. That way, the 420 engine will take up less space. The 670 can be stripped down a little bit with different exhaust system, but overall it takes up a lot more space. From the measurements that I took, we're going to be cutting it real close with the 420 engine. You know, this is a classic case of stuffing 10 pounds of poop in a 5-pound bag, but it can be done, and I've done it before in other projects. I love challenges like this. Now, what's cool about this project is the big part, which is this thing, can be found real cheap. Yeah, our version ain't going to have the big horsepower engine, but it's going to have 4-wheel drive, a locker rear axle, 4-wheel disc brake, high-low range transmission with reverse, and to top it off, an electric winch which will never get used. All for less money than it would cost you to fabricate a crappy little go-kart. In my book, this is a lot of value that we're going to be getting for not much effort, and I love it. So we have a plan, the parts have been ordered, and fabrication will begin shortly. If you want to be kept up to date on how easy it is to build a fully functional UTV from a junk Hisun, consider subscribing. You know, now may be the time to scoop up one of these things if you can find one for cheap. We'll see you next time. Until then.